In this lecture, we will see in detail about the particle in the box problem and its significance. Uh, we are going to see only the conceptual significance of particle in the box problem, uh, not a mathematical part, only the concept, which will be helpful to many audience. First, we will see the solution for infinite potential well problem in the simplest way, that is without much of mathematics. Just I like to explain only the concept. Let us consider the infinite potential well, square well potential with the box length A here. So, then what is the nature of wave function first? Since it is a wave function, maybe in the uh, any of these four form or their linear combination. Since the wave is within the box, it cannot be a exponential term. So e power ikx or e power minus ikx. So it cannot be exponentially. You know it very well. Uh, and then it can be cos kx or sin kx. In the case of cos kx, this box length is from 0 to a. At box length is 0, cos 0 is 1. So, according to the continuity, wave function must be continuous and it must vanish at boundary. Wave function must vanish at the boundary. That is one of the important condition. In the case of position 0, the cos kx x equal to 0, this will be 1. So it cannot be the valid wave function. Cos x also is not valid wave function because wave function will not vanish at the boundary of the box. So the only possible wave function is sin kx. This is the only wave function. So psi x is equal to sin kx. Psi of a is equal to sin ka. It must you go to 0. Sin 0, of course, naturally sin 0 is 0. Only at a it must vanish. At a also it must vanish because wave function must vanish in at the boundaries. So this is possible only when Ka is equal to n pi. So sin pi is equal to 0. N is an integer here. So from this you can understand K is equal to n by A. This A comes to the right hand side. You got this is K is equal to n by A. Uh, what is En, energy state N, that is h cross squared k squared over 2m. This is p squared over 2m. P squared in quantum mechanics, p is h cross k. So this is h cross squared k squared over 2m. Now, from this, we know k is equal to n pi by a. So, n pi by a. So, this will become n squared pi squared over a squared. From this, we can find this. And one more important point is, uh, see, at the boundary wave function has to vanish. So, naturally, I have taken the off wave. So then naturally it will be 0 here and here, 0 to a, it is 0 at the fourth boundary. So it cannot be in between. See, for example, it cannot terminate at this point or this point. It has to exactly terminate at 0. That is a is equal to 0. X-axis is 0. So it has to terminate. This is the wave function psi 1 of x. This is x. It has to vanish. It has to go to 0 at when a is equal to 0. So this may be this half of the wave or full wave. Here also at the boundary 0, the wave function is 0. At a, the wave function is 0. Similarly, it is 3 times uh, that of this one. So you will have n1 node, n2, n3, n4. That is half of the wavelength, full wavelength, one and a half times. That is the wavelength decreases in uh, wavelength decreases in multiple of n. This is twice this frequency. This is thrice this frequency. This is 4 times to the frequency. If you square it, this is x versus wave function. This is x squared versus wave function. I have squared this. So this will be, uh, so naturally now we have seen the nth energy state is n squared pi squared h cross squared over 2ma squared. See, another way of looking into the problem is, as I explained, this is the wavelength, half of the wavelength, and wavelength, full wavelength, this is one and a half times the wavelength. Frequency wise is, if you take, this is a frequency is f, this is 2f, this is 3f, it will go like this. So now the En, nth energy state is h cross squared k squared over 2m. Now you take h cross squared over 2m outside. Then this is node increasing here. You can see uh, 1, 2, twice, thrice, 4 times it increases. So n I have plot. Then what about the k? K is 2 pi by lambda. Here lambda is this one, 0 to a, 2a, 2 times. This is fundamental frequency. So 2a is the fundamental uh, lambda wavelength. So 2 pi by lambda. Lambda is 2a. If you consider the node n equal to 1. So this will get multiplied by n equal to 1, 2, twice, thrice, 4 times. So I am replacing k squared by n, 2 pi by lambda. Lambda is 2a here. So 2, 2 will get cancelled. So this will become n squared pi squared over a square. So exactly same result without any mathematics. We can straight away derive this because k is equal to 2 pi by lambda. From this we got exactly the same result. We will see what is the significance of these results. Now we will see what we learned from infinite square well potential. Just now we have seen nth energy state is equal to n squared pi squared h cross squared over 2ma squared. So from this we learned the quantization because pi squared h cross squared over 2ma squared is a constant term except this n. So the energy is discrete. That is a multiplicative factor of some constant. You are multiplying this by this n squared. So it is discrete, not a continuous one. Then another question is whether n can be zero. This can be zero. Definitely not, because n0 means energy is zero, so particle is at rest, which is against the uncertainty principle. So n cannot be zero. Whether n can take negative value, so even if it is negative value n squared, you are taking square of it, so nothing will happen. After all, it is a scaling factor. So it is simply a scaling factor, and no result will change. Here, another important point is if path's length a decreases, what will happen? See, in the denominator, it is a squared. When a decreases, the energy will increase. that is inversely proportional to a squared. So naturally the energy increases. That means momentum increases. So which is according to the uncertainty principle. If you can measure the position accurately means you bring the Park's length close to zero, then what it means? It means that position is confined in the narrow range. So position you can fix accurately, but what about the momentum? Momentum you cannot fix because it will shoot up. So it confirms the uncertainty principle also. From this problem, we can understand the wave particle duality. Because we are taken particle as an example, we used the wave function. So we dealt with a wave function. That is, a particle behaves like waves, and it is having interference effect and other thing. So mainly we confirmed that wave particle duality. Then energy level spacing. The energy level of the particle in the box are evenly paced. Just now we have seen it is proportional to n square, where n is an integer. So with n is an integer, that is it cannot have zero. This will go as 1, 2, 3 up to n with higher energy level corresponding to more node. I have explained what is node. We have started from one node to node 4. And implication for spectroscopy. The quantization energy level in the particle in the box problem has direct implication for spectroscopy. It helps to explain the discrete spectral line observed in atomic and molecular spectra as well as in various other systems. So now you can understand why we are giving important for the particle in a box problem. So it's a theoretical problem, but it's a foundation and fundamental for the entire quantum mechanics. We have learned so many things from the particle in a box problem. Uh, Thank you very much for watching my video and supporting me continuously.